months ago, I made a new friend. Right when I needed it. Best friend's been there. He's been through it all before me. What happened next is truly for the books. This man opened his heart, he opened his heart to me. He opened his heart for you. So no matter what, no matter what, you've got to roll. Yeah, you can't go slow. Get through this time we're living in. Get your updates from Wages World. You may find yourself in the mirror, quoting yourself, you're looking for answers. Get your space weather from Wages World. The Wages World. Go get it all from Wages World. You check it, you gotta see me coming at me. Gotta get on by 3, gotta tell the world, yep, ready, cause you don't know what's coming. If we're gonna shut down, no, but we're gonna give it to you. If we can, we're going to be prepared. Get your prep on the Wages World. Get your funk with the Wages World, yeah. Maybe we'll have a little Hammerlin Jameson on Wages World, yeah. There's just one show you got to catch. It's Wages World. There's just one show you got to catch. It's Wages World. My brother Wages. Down and into the brother Wages. Down and the brother Wages. Yeah, get the Wages World, yeah. See you me and come up at 3. You gotta get home, get yourself charged, cause you don't know. Gonna take you out, gonna just drop you off the face of the world to the Wages World. Tune in to get your updates. Oh, your updates, Wages World. The Wages World. On the Wages World. On the Wages World. Now you get your updates from Wages World. Get your updates, Wages World. You get your updates from Wages World.
Hey guys, what's up? Hope everybody's having a good one. Somebody give me a 5 for 5 in there if all the audio and everything is okay. I think it probably is, but we'll check it before I get moving. That's right. I'm going to give you some news, guys. Cool. Guys, real quick, chat rules. Yeah, just be respectful of everybody. Can't attack anybody in the chat. Can't mention any other channels negatively. Even if you think I like them or hate them, it doesn't matter. I don't do that here. This is a drama-free zone, so if you got something to say to somebody, go say it to them on their channel. You know what I'm saying? Please don't use my chat for that. But I want to say this. Please, I encourage new ideas. We don't have to agree. We can challenge each other as far as it goes with the idea part, but just no personal attacks. In other words, just be an adult. So my mods know they'll usually give you a warning and all that kind of thing, but you get 2 warnings pretty much. Well, a warning, a timeout, and then you get banned. I don't have very many people on my block list, and that just shows that people can still have free, not really be censored, but at the same time, have a good experience and still get their voice heard, I understand that. I know people like to have their voice heard, and that I do too. So, hey, Rip, what's up, man? Ain't seen you in a minute. Me and my wife was thinking about starting a garden. So we may end up doing that, thanks to you. So, if you guys don't know who Rip is, please go check out Rip Curl. He does a lot of preparedness videos. He's doing gardening stuff right now, and showing you how to get ammo and all that kind of stuff. Hey, Wolfie, what's up? Muse. Everybody else. So yeah, I'm gonna go ahead and put the chat away so we can get to the data. Okay, guys. Anyway, guys. Yeah. So look here. Obviously, big spike. I don't want to over dramatize that but it is significant. Okay. Also, I want to say this too. Go check out Verte's channel, Verte Arbuoto. Guys, he really does a really good job explaining what this tool is showing you. He said something in his last video. This right here is not an optical telescope. Okay. Actually, I'm going to bring the chat back up for this one because I want you guys to understand this one. Okay. This is not showing you anything visually. This is taking data and showing you frequency, and it's just giving us something here to look at so we have something that we can compare it to with our eyes. So, anytime you see shapes and things like that on here, it is not, guys, I'm just going to say it's not a planet. All right. It's not nothing like that. For a whole lot of reasons. The Schumann Resonance bounces around between our ionosphere and the surface of the Earth. Okay. Yes, it's influenced by things like space weather and other things. But at the same time, it's not going to, when you see these shapes, especially when they're like this big, you're talking almost 10 hours of data plotting. See the hours here? That right there in itself pretty much will tell you that did not, it's not like that. So I just want everybody to understand that. But, so I'm going to go ahead and put the chat back away. But guys, listen, these things, the Schumann can make you sick. It can make you feel really bad. Ringing in your ears is a really, really, really big one that most people experience. Now, for our human biology, we pretty much require a 7.83, okay, to stay. That's what they consider. That's what they tell us and all that kind of stuff. And that's right here on this line. Now, remember, a data point's vertical here. It's not horizontal or a dot. This is how they plot this. But it goes from low to high from top to bottom. That's the other thing that's kind of weird about this graph itself. This graph is in Russia. This is a localized thing. You can actually get resonance detectors and put them in your yard if you want. Put them at your house, that kind of thing. That's how this can really get down to it. It's a very localized thing most of the time. When we have the global events, it'll go across all the tools. So, but I show you guys this one because this is the most important thing to me. And I think it should be to everybody else too. I've been saying that for almost a year now. When we see this thing get all jacked up, everything else is going to be jacked up too. And we're all going to start feeling bad and all of that. So That's just what happens. And, put it in the space station, people work underground, all that kind of stuff. But as far as what's going on right now, yeah, that's a significant spike. Now it's over, okay, as for right now. But back here, then the day before that, we actually had a pretty decent sized spike. Kind of took this same, again, guys, shape really doesn't mean a whole lot here. But at the same time, it was looked kind of like this, but just a little bit bigger and a little bit more intense. That's all. Now, this is really kind of a more typical spike of what we see. This one and this one. So if you were feeling bad and all that kind of stuff, wasn't feeling quite right, this could be it. But let me tell you something. First and foremost, don't just automatically blame it on the Schumann if you're feeling bad. Okay? If you cannot directly relate it back to that, please go to the doctor. Please. Just do yourself a favor. Especially if it's serious stuff. Okay? So, what's going on space weather-wise? Well, we got, little pops, little flares going on here. Not a whole lot when it comes to the flare issue. Geomagnetic activity is actually low now. We got into storm level. The G2 storm never happened. Okay? We kind of peaked here and we peaked here again. Down and up. It was kind of like a double smack. And that's kind of what I was saying was going to happen. Wasn't quite sure if it was going to pan out that way, but it did. Just not necessarily on the same timeline. And I think why we didn't get to G2 is because it got here slower. So that means it was moving slower. The speed of it was slow than what we thought. If it had gotten here on time, we may have gotten up to a KP of 6, which would have been a G2 storm. But we didn't. So this is what we're experiencing now. Now our magnetosphere is actually reacting right now too, kind of crazy looking stuff. And I'll show it to you guys here in just a second. But this right here, that's like 3 sunspots. Okay, it's a big grouping, and I think they have it like 3 official sunspots in there right now. Or maybe 2. 2 of them, I think. We'll take a look here in a second. I know we have 4 of them on the front. I'm not sure if it's this one, and 2 more, or if it's like this one, and there are like 3 of them here. Well, we'll just look now. Okay, it's right here. Okay, so yeah, we got 3 of them right here. You're probably asking yourself, what makes it a sunspot? Well, there's some parameters there that they have to go by. I'm not going to get into details on that today. But just notice that when they're this close to each other, obviously they have a lot better chance of reacting with each other, thus destabilizing things, and we get eruptions, flares, that kind of thing. Okay, and that's definitely what we're seeing. Guys, we had like 2 CMEs yesterday. Now, they weren't both coming at us, but it's significant stuff. Okay, just understand that, okay? The sun's woke up now. It's not going back to sleep. No time soon. We may not have sunspots always facing us, but for the most part, the sun's going to stay active from here on out. At least that's how I think. That's what I think is going to happen. So, obviously, if we look at the other stuff here, the other data points, this is density here. The green line's at Earth. This is NOAA's forecasting model. Again, 2 days behind, and they try to forecast that 5 days out in advance. This is because of other eruptions and stuff that have happened. I guess I could just do this real quick. So if you watch up here, you'll see stuff come off of the sun and come our direction. See that? Those are other eruptions. Now, we just had a filament come off the sun just a few hours ago, and I'll show it to you guys here in just a second. But notice how steady and kind of smooth this electron flux was, and now it started doing all this. And that's exactly what we're seeing here, too, on the electron content overall. Even though we're not in geomagnetic, storm levels, we're actually kind of low geomagnetically. We have a lot of electrons right now. And that can do stuff, too. Okay? So, I want to point that out. Now here's our aurora. Obviously that's back yesterday when we were during the storm level. Okay, so that's what that was. Now it does look like we're starting to peak up again. See how we got kind of right there? So I'm going to be interested to see if this thing doesn't start. Well, it started to come back up again anyway. I was looking at the Discover data here, and everything's on the uptick here. Okay, when you get a density uptick, usually the speed's going down, and it is. So 10 is what we look for density, 10 or above. It's not nowhere near that yet. It's about halfway there. As far as wind speed, 3 to 500. There you go with that. Not even, we're kind of on the high end of that, but not out of parameter there. The BZ is what's important right now. It's usually what's important all the time. That's the angle of which the solar weather gets in. Okay? Basically, it's our magnetic field, the angle of which that it's pointing. And depending on what angle it's pointing, it allows stuff to come in. Remember, solar wind is charged particles. And it gets to the Earth via a magnetic connection line. All right? An IMF line. It travels that line. So if that angle is kind of not, at the right at the right place, it kind of even can sometimes deflect that stuff. But so we look for -6 here, and that's not where we're at. So that's probably why our geomagnetism isn't really bumping up that far. If our BZ had already went to -6 or bigger here, with this density increase and all this other stuff going on right here, we probably would be a little bit more active geomagnetically. Before I show you guys that, I'm going to show you guys 3 different magnetosphere tools also. I've shown them to you guys before. Here's the newest one, okay? So let me just play this one. This is the speed, okay? This is density. Dark is more dense. Notice how you're getting waves of stuff coming in through there, especially towards the end. All right? Here's pressure. So, we got a lot of stuff hanging around right here. And I will say that, like that. That's kind of a strange looking signature, I will say. A lot of heating on the backside here. A lot of pressure, okay? More so on the back than we're seeing in the front. So take that for what it's worth. There's a lot of different things there we could talk about. And there's a lot of different theories and ideas and all that kind of thing that people think is what's going on and all that. And once again, I'm not here to tell you guys what to think. I will show you the data, and this is what we're seeing. That's backside pressure. There's no doubt in that. So, wherever it's coming from, that's where it's coming from, and it's way more intense than what we got going on in the front. That's a little strange. That's what I will say. I mean, I don't think, see how it kind of went from that? That would be more normal looking to me. And then as we go through there, it looks as though things have just kind of flipped over there. Now, this is the Australian model. And I haven't shown you guys this in a minute. Notice that, it shows you the BZ here too. I like this one because it's really simple. This is representing the bow shock. Our first line of defense, pretty much. That's where the solar wind meets our magnetic field. Okay, that's that line. So what it does is, when energy hits that, it has to go somewhere. It either has to be absorbed or it has to be deflected. And the majority of it gets deflected. Okay, that's why it's arced like it is. They call it a bow shock pretty much for the same reason why when a boat's going through the water, that kind of thing. It's actually kind of similar to that anyway, as we're traveling through space. So if I play this one, well, let's just back it up to the 26. You'll see this, and what I like about this one, it gives us one every minute. Okay, it gives us a capture every minute, a data plot. And notice how things are bouncing. And I've shown you guys this before. I just haven't shown it to you guys in a while. But it shows your density here, your solar wind speed here, and your BZ, which is usually the most important data points we need to be looking at. It is getting pushed on all kinds of crazy ways. So if we go here, this is the ISPA models. Okay. I know that these are the older models, but I still think that they're valid. They were good enough for however many years I just don't see them how all of a sudden they could just not be no good. It just doesn't make any sense to me. Even at that, even if you think that they're not, whatever, you can still compare what we're seeing now to what we've seen in the past, and still get some sort of an idea of what it should look like. And so with that, keeping that in mind, you take this and you start seeing stuff like this. Watch. Okay, this is, typically when we see these kinds of that amount right there, it's usually closer. This is standing off our backside quite a bit. Okay, than what we typically see. It's usually a lot closer than that when we start seeing that pressure there. Obviously, like I said, we do have some solar weather and stuff that we need to, consider here. And we also, one thing that we do have to keep in mind when we are looking at this is the fact that this is a two-dimensional model. And it's trying to represent something three-dimensional. So, just pretend that, it's like our magnetosphere is kind of like a blanket that wraps around us, but it's open in the back. So if you can take, like, this is the Earth right here, and kind of just picture grabbing that blanket right there and pulling it close to your face. Okay? So it kind of pulls everything. It's three-dimensional. It's more like a tube, I guess, and we're kind of in the middle of it, or a donut cut in half. However you want to explain that. I know it's kind of hard to understand that. But what I'm saying is sometimes when we get hit, from whatever direction we're getting hit from, it'll hit and it'll look like it's going straight through. In reality, what it's doing is it'll hit here and kind of come closer to us and still go around our planet. Okay, our bow shock is not just a line. It is, it's three-dimensional. I guess it kind of looks like a slinky, if you want to go that route with it. That's actually a pretty good analogy there. But anyway, this is another way that we can look at our data. And like I said, guys, what we're seeing right here isn't what we usually see every day. So it is interesting that, we're getting stuff here and not here. We are getting some up here, but it's just it is kind of nuts. Now, I will say this too about this one. Okay. You see this dark orange line? I've not seen that very often happen behind us like that. So we're getting some, some heating and stuff going on, especially there on the backside. When you see the oranges here on the backside and it's blue in the front, it is it's just strange. So again, like I said, I'm showing you observation and just going to move on from that because I understand. I really do. And I'm not going to tell people what to think. So, but anyway, here is IMF lines, pole lines, all the above. Okay, it's just another way to look at this, and this will give you an idea of actually how we're kind of arcing like this here on the end. You'll see how everything kind of getting pulled down this way and getting pulled down in the front there. So, watch what happens here. I know I'm kind of flipping through that kind of fast. I just don't have a whole lot of time here, guys. So yeah. You can see that. You can even see, even here, how heat's building right there. Lots and lots of heat coming in this way. It's our bow shock and all that. And again, guys, have we seen these kinds of things before? Yeah, we have. As a matter of fact, I think I was looking at that earlier. What was that at? I had I think it was on one of my videos or something back in 2019. I was showing, and it looked very similar to this. So yeah. Where the heck did I do with that? That's ridiculous. What the heck did I do with that? Did I leave it on this one? No? Huh. Okay. Anyway, I'll show that to you guys later. But yeah, this is something we don't see all the time. But we do see it every once in a while. Things are kind of lopsided, and it's yeah. Anyway, seeds. Okay, you're looking at CMEs and all the above there. Again, we're having lots and lots of ejections off the sun. Let me show you the stereo A here. This was interesting, really interesting. Watch what happens. Okay, here the satellite's here, right? Earth is here, so this is a side view. Watch this one blow off. Okay, watch this thing. See it blow off? Now watch, look at that. That was very interesting to look at. We don't typically see them be that concentrated and bright that far out after they eject. Usually they kind of spread out real fast. That seems to be a little bit more concentrated. And obviously, is that going to come at us? We can look at the CME tracker. Do I have it up? That is that ejection right there. So I do think that we have a chance of this thing grazing us. Because all three of them are kind of showing it hitting us a little bit, just kind of on the side. But again, a grazing's a grazing. That is what it is. Typically, a grazing doesn't really do a whole lot. I'll just say that. Sometimes it'll get us into storm level, sometimes it won't. This is our geoelectric field model. Not a whole lot going on here. You're seeing some pulsing. All right, what you're seeing here, guys, is space weather's effect on our electrical grid. And this one's three-dimensional. That's why it's still in prototype stages, like beta testing and stuff. That's why this isn't completed here on the model. But this one is. This is a one-dimensional model. It does good for what we need it to do. And so you're seeing there, when we get hit with certain solar wind or increased speed or density, hits from space weather, okay? This is the chances of it, affecting our electrical grid. When we start seeing the reds and the purples and stuff like that, that's when we like, oh, okay, maybe we better stop and look at that. But I've even seen it look like this and actually have an effect on like people watching TV, like their cable and stuff. For whatever reason, whatever area I'm in, it does affect me more often than it does others. And I would think that that's probably normal in some areas. So I'm just probably in one of those kind of a dead spot type of situation. So any kind of extra interruptions will, cause me to have a whole lot of digital blockouts and stuff on my cable TV and all that kind of stuff. So I do want to show you guys this filament. Okay, it's right down here. I'm going to zoom in pretty far so you guys get a good look at this. Yeah. Is everybody okay in there, guys? Let me let that catch up. So, yeah. Is everybody okay in there? All right, cool, Rip. Sweet. Hello to everybody in there, guys. I wish I could say hi to everybody in there. I just don't have the time right now, guys. But anyway, you got a filament here, guys, okay? You can kind of see the dark shadow. So what I'm going to do is I'm going to run this back a little bit. And remember yesterday on my video when I commented how this thing was large and draping all the way across the bottom of the sun? Well, that thing finally snapped off. Okay, so watch what happens here. Am I zoomed in all the way? Nope. I'm going to zoom in all the way here so you guys get a really good look at this. Sorry about that. Okay, so you got this right here. And you can see it starting to lift off here. And then it snaps off. Wham. Okay, now I know that doesn't look too intense or impressive. But the reason it doesn't is because the sun itself is the background. If this was out over the side of the limb, that thing would look huge. That's a big one, okay? That's a big filament that's lifting off there, and we're going to have to wait and see if it's coming at us or not. It is in front of us, okay? But sometimes when these filaments, whip off, they whip off in weird directions, okay? They go at different angles and all that kind of thing. So we're just going to have to watch that. Notice this grouping here, guys. When you're looking at the 304 angstrom and you see this much brightness, you know that that's an intense part of the sun going on right now. That's where those 3 sunspots are. So, take that for what it's worth. You can see them kind of flaring every once in a while. No big ones or anything like that, but they are flaring. Actually, you can see this filament all the way through here. So I'll run it back and forth. You see it moving there? Okay. Now, again, not all of that left the sun. Okay. It looks like it snapped off and some of it left and some of it got recaptured. And that's very typical because these are magnetic connection lines and charged particles travel those lines. So, they snap off, but then the sun will it'll reconnect and those particles will start going back to the sun. That's what plasma is. It's charged gas. Okay? It's like it ate a bunch of beans or Taco Bell or something. Just kidding. Anyway, here's the 171 angstrom. Okay, this is going to give you another look, but there was that one ejection up here. Watch up here real quick. See that? That's not going to come at us. That's why I'm not wasting too much time on it. But notice the difference here of the 171. We're not going to be able to see much here. You're going to see a little. See that? That's all you're going to get to see. See? It's because the sun's the background and we're looking at the 171 angstrom. We're looking at a different gas, a different part of the light spectrum. 171 to 304. That's the difference that we're doing here. So if I look at that one again, you see how clear that comes out? Now, but if I wanted to show more of the corona, this one ain't going to show much of that. This one does. You can clearly see it. So that's why we look at different angstroms. That's a question I get a lot of. Why do we do that? Why do we look at different angstroms? Why are we doing this? Why are we doing that? That kind of a thing, right? Okay, so again, 4 sunspots. One thing I do want to point out, guys, we cannot let our guard down when it comes to these coronal holes. Okay? Believe it or not, the majority of the time when we're getting space weather, upticks, they're coming from coronal holes. You get charged particles just rushing out of those. So that's usually, especially if we're getting that, plus we get a CME with it, that's when we get the big ones, okay? That's when we get bigger hits on geomagnetically. That's when we have to worry about power outages and all that kind of stuff, right? Now, if we get a big CME, obviously, everything's on the table at that point. So, but you can see, this is a bigger hole, guys, and it, Earth is right here. Okay, so they call it going through the Earth strike zone. It's it's right in front of us, because this is from is this SDO? Yep, this one's SDO. So this is from our point of view. The satellite sits right in front of Earth, looking at the sun all the time. So that's what this is doing. This is from our perspective. There you go. So this, the sun rotates, okay, just like the Earth does. But one thing I want to point out here, and this does mean a lot of different things. It really does affect almost everything we're talking about when we're talking about the sun, is the fact that the equator rotates at a different speed than what the poles do on the sun. That is the biggest reason we get sunspots in the northern and southern hemispheres at different times. Because it's all getting wound up. When the sun cycle switches to a new sun cycle, the magnet basically it gets, the dipole part of it gets reset. And they're vertical. Okay, they're traveling vertically. But because of that rotation, that magnetism gets pulled that way, And because of the difference of speed between the equator and the poles rotating at different speeds, it winds things up and it makes them go, it gets pulled horizontal as time goes on. And when you get kinks in those magnetic field lines as they're getting pulled, that's when you get the sunspots poking out. Okay, now I know that was really quick and I threw a whole lot of information there to you. I went over that before, but that is a basic, like very, very basic reason why we see sunspots at all. Just remember, it's magnetic. So, you got north-south travel here, and because the difference in speed between the equator and the poles of the sun, things get stretched horizontal. If everything was moving at the same speed, they wouldn't get pulled. Okay, everything would just stay vertical. That's how that would work. But because of that the difference in speed that it rotates, that's why we see these things. Okay? I know I just threw a whole lot at you there. Everybody understand that? Somebody give me a yes, no question, anything? Just want to make sure, because that was a lot of stuff I just threw at you. I apologize for that. It was a lot. All right, cool. Cheryl, okay. Thanks, Muse. All right, cool. And I will go more in depth on that, okay, at some point. Cheryl, you got, what kind of questions you got? The equator of the sun rotates. Let's just say it's rotating at 50 miles per hour. We'll go real basic with it. And the poles are rotating at 30. So that means anything here, the line's magnetism starts vertical when we switch to new sun cycle. So the more as time goes on, those magnetic lines start looking like this. Okay, they start getting pulled like that. And then eventually, instead of being vertical, they're just straight horizontal. Because it's the equator of the sun is rotating faster than the poles. So I hope you guys understood that. So yeah. Kuiper belt warping. Yeah, Cindy, I seen something on that. I just haven't really read into that yet. So, yeah, kinda. That's right, G513. Good to see you, by the way. Yeah. So, let me put you back away for a minute. Earthquakes. I just checked this a few minutes ago. We are getting quite a bit of 5s popping off here. There were like 3 5s right here. 1 here. Down here. Again, I'm not the earthquake guy, but I will show you guys this so you guys know what's going on with it anyway. These are all reported for USGS. Now, remember, USGS is based here in our country, right? That's why we're seeing the little ones here in our country. All right, that's why you're not seeing them over here. Make no mistake that there's little ones going on all over the planet. Okay, we're just not able to see all of them here on the USGS. They don't plot them all, so that's what's up with that. Just understand that. So I get a lot of questions on that. Why don't we see a whole bunch down here or over here? Certain areas of the planet aren't going to have a whole lot anyway. But at the same time, now I guess I could show you guys this one. I haven't shown you guys this in a minute. This is a Canadian site that plots earthquakes. Okay, now they do it every 30 days, I believe. But, I had one question. Somebody asked me, why do the earthquakes stop at the Canadian border? Well, they don't. It's just that the USGS doesn't plot them. So this is a Canadian site. So I can't remember who gave me this link to this, but whoever did, thank you if you're here. I was showing it for a while, but you can see. Also, the the Cascadia subduction zone, guys. We did have a decent sized 4 there today. Anytime we see stuff out here in this area, it does raise bells for everybody, because when that subduction zone finally does slip, the whole West Coast is going to be redefined. There's nobody out there, including mainstream media, mainstream science. They all agree with that. I mean, that is what it is. That's what will happen. You know, you will have beachfront property in Arizona. That's just yeah. When that thing slips, I mean, there's going to be some big time stuff going on there. But that's why we pay attention to it, right? No fear, no fear, no fear. So don't ever get like that. It's no use in fearing anything. We can't control it. Don't fear stuff you can't control. Just be aware of it and control what you can. And that's what you do. That's your actions. That's the actions that you do to be either prepared, helping other people out, whatever. That's what you do. You don't run around in fear. If you remember back to when you were the most scared in your life, what was it? Most likely it had something to do with being shocked with something. Like somebody jumped out from a corner, or you didn't expect something to happen and all of a sudden it did and you got really scared. Well, if you're aware of stuff, that shock factor is gone. That's why I do what I do. I want to get rid of that shock factor for people. I want to give people a way to go look at this stuff and, you know, make their own decisions. Don't listen to a word I say. Please don't. You know, listen, I guess listen to me, but don't, you know, go research it yourself. You don't have to believe me is what I'm saying. Please go look. That's why I've been saying that for almost 2 years now. You know, that's what I want. I don't want to, you know, funnel anybody's mindset. That's not my goal. My goal is to give you guys new stuff to look at and ways to go look at it. And hopefully I can help you understand what you're looking at. Now, what's causing those kinds of things is up for you to decide. That's you know, that's kind of what I do. So, hopefully you guys get that. But let's refresh the Schumann here real quick before we get off of here. Okay, nothing going on there. All right, let's look at the. Where's the discovered data at? I just had it. Okay, right there, guys. Yeah, you see this? See the density spiking up, almost to 10 there. Then it dropped back down. That's kind of strange. The wind speed went up too. So who knows? Who knows what's going on with that? But yeah. So you guys okay in there? You guys okay? Give me a 5 for 5. Hope everybody's all right. Guys, I'm going to be heading over here. There's a link for you. I'm going to be in the chat. If you guys want to come hang out with me, I'm going to go over to Mark's channel tonight and go hang out, listen to some good music and all the above, guys. Thanks, Daniel. Appreciate it. What's up, Arizona? E-Rock, Chris, PCM, good to see you. Muse, X. Who else am I missing here? Cheryl, Chris, Schumann Show, Stacy, Tech, Jules, Jotty, Daniel, Muse, and Marie. What's up? Thank you. Guys, thanks to all my mods. Thanks to all my subscribers. Guys, I can't tell you how much I appreciate you. Hey, Steven, what's up? ZG, what's happening? So, yeah. I will most definitely be heading over there, guys. So, if you could, you know, here, I'll drop the link again. Paste. Somebody asking me something up here? Could you ask Mark Pires to, I can say something to him, Daniel. You know, I don't know what happened there on all that. But that, you know, I'll say something to him. I'll ask him what's up. It's up to him. But yeah, I can do that. But anyway, guys, I am going to go ahead and get off here. Sorry about that. But yeah, love you guys. God bless. Yahusha saves, and you can drink this.